In this video, I'll show you how to set up and manage live stream. In this video, I'll show you how to
Hello. Hi, Ian, is that you? No worries.
Hello.
Hi, Ian, is that you? No worries.
Hello.
Hi, Ian, is that you? No worries.
Hello.
Hi, Ian, is that you? No worries.
Hello.
Hi, Ian, is that you? No worries. Hi, Ian, is that you? No worries. No worries. No worries. I've actually never done a meet streamed to
No worries.
YouTube
No
live stream,
worries.
so this is pretty cool. I've actually never done a meet streamed to
No worries.
YouTube live. Technology has conserved the audio seems to be coming through great, so something else had to, break down, preserve the balance of the universe. Yeah, let me switch my turn on my presentation here so that we can make sure that all looks good. Just turn off my video. Yeah, let me switch my how's that look? Presentation here so that we can make sure that all looks good. Just turn off my video. Yeah, let me switch. All right. Cool. Well, thanks so much, Ian, for hosting. I'm very excited to talk and share. So this presentation is going to be about writing robust Flask apps, but robust in this context really means robust from the security perspective. So there's going to be a lot of OWASP specifics. We're going to be talking about the OWASP top 10 as applied to Flask apps. And it's actually pretty relevant for Django apps as well. So since those two frameworks have a bunch of stuff in common, pay attention even if you use Django. This was actually a talk that was originally accepted at PyCon. So it used to be a more tutorial style and even longer. We've pared it down for presentation at the meetup tonight. But feel free to, Ian, unfortunately, I can't see the chat. I don't know if you're able to, but if you want to call out questions as people go, I'm happy to be interrupted. Won't bother me at all. Awesome. Great. So just a little bit of background on me. I'm one of the co-founders at R2C. Was formerly at MIT and MIT Lincoln Labs, did some offensive work at US DoD under a Scholarship for Service program. And our mission at RTC is really to automate security as much as possible for developers. And to that end, we've been releasing open source tools and then providing commercial services and support for bigger companies on top of them. In fact, one of those open source tools we'll talk about tonight. So there's going to be a number of tools that we'll talk about under the category of automating security. Many of them have been around for a couple of years, but just to give you a highlight up front, here's the too long did not watch for this talk. Writing a secure Flask and Django app is sort of frustratingly hard in that there are lots of gotchas and sharp edges that can bite you. The most important things you can do are to keep your frameworks up to date and read the documentation, because if a hacker knows more about your framework than you do, you're going to have a bad time. On the flip side, if you are the hacker, you want to read the documentation so that you know more about it than the defenders. And as much as possible, check your code with code. So SymGrep is a tool that's kind of like grep, but specifically designed for code that we've written about 170 checks in for both Flask and Django, some of them in collaboration actually with Jacob Kaplan-Moss, who's one of the co-creators of Django, which is pretty neat. So the fundamental question that we're going to zoom in on is, all right, we've just written app.py. That's our glorious Python web app. And now we're about to put it on some server, expose it to the whole internet. And we want to know, after we typed Python app.py enter, is our application secure? To do this, there are sort of three levels that we're going to look at tonight. The first one is understanding the stack. So there's a lot going on underneath that command. What does that imply for our security? And then when we come back to the just our Python code, what kinds of vulnerabilities even exist in the first place, and how can we find them? And then the last thing we'll talk about is, the dream here is to be able to automate as much as possible any kind of advice that I'm giving you. So understanding the stack is the first thing. The good news here is that we use Python. So automatically out of the box, we're just immune to a lot of different attacks. So for instance, heap and buffer overflows, which have long been the scourge of C or C++ programs. For instance, with stack smashing attacks, some of the stuff that I used to work on in a past life, generally don't have to worry about that. Python is memory safe, and in fact, most kinds of memory disclosures, like the heartbleed bug illustrated so well by the XKCD on the right, we ought to be immune from as well. But there are a few interesting caveats to this. The first one is that memory leaks are actually memory safe. So, if you've ever used a very large machine learning framework, they've had a couple notable bugs in this way. It's entirely possible for your Python application to just leak gobs and gobs of memory in a way that could result in a denial of service situation or something like that, even though, it's pure Python and it's, written in a memory safe language. The other thing is that just because somebody tells you, oh, look, my Python application, I definitely don't have any of these bugs, plenty of Python modules are actually written in C. So for example, if you've ever used NumPy, numpy.empty actually allocates uninitialized memory. So if you really tried hard and for some reason you were exposing a numpy array directly to the user of your web application, you definitely could replicate something like Heartbleed in Python. Which is kind of cool if you're an attacker and a little bit terrifying if you're a defender. The point is that you can't just assume that because my application is written in Python, all of the dependencies of that application are written in Python. And in fact, here's a very simplified model of kind of what's sitting beneath our little Python web application. So we've got our app.py, which I'm just using as a placeholder for all of the code we wrote. Beneath that, you've got your built-in or third-party libraries, so things like Flask and Django live here. Beneath that, of course, Python is just a language. It's not actually a program. You need a specific program that you're going to install in your machine in order to interpret and execute that Python code. If you've installed Python through the normal channels, the implementation you have is probably called CPython, which, as its name suggests, is largely written in C. As a C program that's going to link against the C standard library for your operating system, which on most Linuxes will be libc. If you're using an Alpine Linux distribution, it would be Muscle. If you're running on Windows, it would be something called the CRT. And then, obviously, you've got the operating system underneath that. The good news with these bottom layers of the stack is that fundamentally they're somebody else's responsibility to find and fix security problems in. The bad news is you have to stay up to date. And just to give you a sense of how significant that is, here is a list of security vulnerabilities in Python and the Python core modules. Actually, one of our new team members who joined us in January is responsible for one of the top ones on the right, one of the 2020 CVEs, which got a high impact rating in the Python core, which is super cool. But there's a constant stream of these things. It's not every day, but at least once a month, there's some sort of vulnerability that comes through. So this means that, unfortunately, you're strapped in the sort of age-old security dilemma, right? Your security software is out of date. You can either spend the rest of your natural life figuring out how to go through some sort of upgrade hell, or let hackers destroy your hard drives. And it's just a paradox that you have to live with. But there are some specific recommendations that can make things easier. So, if you've ever managed dependencies in Python, you're probably familiar with a requirements.txt file, which lets you specify, hey, these are the modules that you need to pip install and the specific versions that I expect to work with my application. There are some new specs for Python, a document called a pip file and a pipfile.lock, which let you, if you've ever used JavaScript, it's very similar to a yarn.lock or a package JSON.lock. And it basically specifies the full transitive dependency tree. So your dependencies, et cetera, all the way down to the bottom of that pile of turtle shells. And it also hard codes the expected SHA sums of the executable code that you're downloading whenever you do an install of those dependencies. So it's basically a way to create just like a frozen lock of these are exactly the dependencies on machine A. When I install it on machine B, it should be exactly the same thing. And there are two package managers that have emerged in recent years. Pipenv is a little bit older and more popular. Poetry is a little bit newer, but potentially easier to use. And they both make it really easy. They will automatically, convert your requirements.txt to a pip file, and they can also be used to just update all of the third-party libraries for you in one command, which is a huge improvement. So that kind of covers third-party libraries. For Python itself, there's not, unfortunately, a security mailing list that's just dedicated to security releases, as far as I know. So your best bet is to just find some sort of way to subscribe to releases of the Python interpreter that you use, so that you can get notified when there's a new, even minor release that might have a security update. And then, of course, the age-old advice applies to, well, your operating system base image is definitely going to have vulnerabilities that you need to keep track of. It can all get a little bit overwhelming. There are a couple services that have support for Python specifically in terms of prioritization. So GitHub now has a free feature, which you might have gotten some spam from, about security alerts, which can tell you about vulnerabilities in your packages. And then there's snick.io and pyapp.io, which are both commercial services. I'm not affiliated with them, but they have some prioritization for those security feeds. Any questions on this in the chat, or maybe feedback from you, Ian, before I keep moving? Cool. Awesome. So the next area of the stack, the interaction between your Python code and the built-in libraries, this is your responsibility. And that's going to take us into the second and much longer part of the presentation, which is what are the possible vulnerabilities here and how can we actually find them? So the first thing is, we need a kind of ontology of vulnerabilities. OWASP actually, obviously has a great one, which is based on empirically, hey, this is how people with web apps are getting hacked. MITRE, their common weaknesses enumeration framework, is the most extensive one. If you've heard of CVEs, I'm guessing you have. CWEs are kind of just the method by which the CVE exists. So you've got a vulnerability. That vulnerability stems from some weakness in the application, and a CWE is just a very long list of all the weaknesses people have found over the years. So in terms of my philosophy here, just personally, I feel like people oftentimes put a lot of energy into one part of the application at the expense of doing things consistently across the whole application. So, somebody will spend a lot of time making sure their authorization is really nailed down. But being consistent and picking things that are simple solutions rather than like a very complicated answer to a security problem, just kind of philosophically, I think actually tie well both from a security context into the Python context, where simple is better than complicated is also one of the guiding principles. So here is the OWASP top 10. I'm imagining you're fairly familiar with this. I'm going to zero in on a couple that I think are specifically interesting for Flask and Django. We'll talk about injection, XML, XXE, security misconfiguration, cross-site scripting, and insecure deserialization. The other ones, although they're interesting, they're perhaps not as unexpected or gotcha inducing. So we just won't have time to cover them tonight. We're going to start actually with security misconfiguration, just because this is some of the highest bang for your buck in terms of how easy it is to get hacked. So there are actually two problems with this Flask application. One of them might be more obvious than the other. If you're familiar with Flask, you're probably like, oh yes, I know what this problem is. But in terms of leverage, this is one of the easiest ways to get hacked running your Flask app. So this is very basic. If you're not familiar with Flask, we've basically just imported it. We added a logging framework. We initialized it. And then we have a single route. This decorator is going to make any request that goes to the index is just going to get a very blank body response. Great. So what's the problem? Well, the problem is that there's a single line of code here, which actually has been responsible for at least one publicly discussed vulnerability and probably many more. I could give you some anecdotes of surprisingly large companies that have had this. And if we go back and look at that code, it's this app.debug equals true. App.secret key is also kind of a gimme. You shouldn't be using a development key in production. But it turns out that Flask uses a debugger, which by default, if you enable the debug mode, will actually allow anybody who gets a HTTP 500 error page to type in arbitrary code, which will then be executed in the context of the application, which is great for debugging and also great for hacking web applications, as it turns out. So here is a one-line way to just give anybody on the internet arbitrary code execution on your web app. It's great. Very high ROI. How can we prevent this sort of thing? How would we even discover it in the first place? So if you read, if you run an application with debug equals true, it will tell you, hey, you should never do this in production, but it won't say you should never do this in production. You will get hacked, even though that's pretty sure that's what's going to happen. So unfortunately, the only recommendation we can give here is yeah, you got to read the documentation for the framework. You have to pay attention to the notes, these little call outs like this one from the Python 3.7 side on the right from the Python 3.7 docs that are kind of the security gotchas. Another thing that a lot of teams do is they'll use a code owners file, which is a way both GitHub and GitLab support this, that you can mark certain people as mandatory reviewers for any changes to a file. So if like, yeah, well, not everybody's an expert on Flask, but at least like our conf.py, configuration file, if somebody's messing around with that, maybe the one person who is more of an expert in Flask can be marked as a mandatory reviewer. And of course, the third recommendation is, well, it'd be great to automate finding these issues as much as possible. And I'm going to show you an example of what that might look like in just a minute. Security misconfiguration is such a landfield or minefield, and also there's so many opportunities in Slack or in Flask that I'm going to show you another one. And this one actually was a bug that was found on Netflix.com live in March. So pretty relevant. And it specifically deals with a section of code that looks like this. So if you're not super familiar with Flask, we're using the Flask built-in session manager to store a user ID, inside this little snippet. This looks pretty innocent. It's definitely the sort of thing that you could see in like a Flask tutorial or a Stack Overflow answer. But out of the box, there are actually 3 problems with this. And if you're familiar with cookie security, you're probably like, oh, yep. First off, the cookie could be requested by default, just with the default Flask settings over an HTTP connection. It's not required to only go over HTTPS. It could be read via JavaScript, which is not necessarily bad, but is basically a super simple escalation vector if there's any kind of XSS. And then it's also susceptible to cross-site request forgery of the cookie, so CSRF. And the good news, I guess, is that there's fairly straightforward recommendations if you read the Flask documentation about for each of these things. You just need to set some flags either in the config or for every cookie that you create independently. You also need to explicitly set these things. So the first example is going to do it anytime we use the session object. But the second example, anytime somebody is manually creating a cookie, you really want to make sure that they use this secure flag, the HTTP only flag, and that they have some sort of sensible policy set up for the same site. So we're going to now talk about, okay, like this is a great example of a gotcha that we ought to be able to use some tools to try to find. Where there's free tools available for Python, there are proprietary tools as well. Under the free category, we have grep as an option, which you may not have thought about as a security tool, but it is very fast and it supports an infinite number of languages. I've actually been really surprised at how many security teams are getting a lot of leverage out of grep. Bandit is a tool it's a bit older now. It has about 64 security rules. It does not have one specifically for Flask, but for other frameworks like Django, it has a couple rules. DLint is by Duo Security. It has a smaller number of rules, but it's a bit more tuned and it's just also generally newer and faster. And then if you've used a linter like Flake 8, there are some plugins that are security related for tools like that. SemGrep is a tool by R2C, and we've working with Django and getting some advice from Flask folks, written about 170 checks that cover these frameworks specifically. So we'll talk about that in a minute. And of course, there are also some proprietary and closed license tools. So SonarPython, Coverity, Fortify, Veracode checkmarks. To be honest, these tools' wheelhouse is not generally speaking Python. As far as I know, none of them cover Flask, except maybe the debug equals true thing, just because that was such a glaring gap in the security of the framework. Most of them are optimized for C, C++, Javas of the world. And in fact, I think that the Python space is particularly underserved by the commercial products. But let's come back to grep. So imagine we're looking in the code base and we see something like this going on. So we've got some index route, response.set cookie, username. Oh, that's me. And we're thinking back to, there was that recommendation just a few slides ago that said, oh, do this for all cookies you create. Well, how could we use grep to just automatically detect where people are not doing this? So here's a really simple example. We're using the -r flag, so that's recursive. We've escaped the dot and the open parentheses. So anytime somebody has an object named response and they call the set cookie method on it with an open paren, presumably starting a function call, this is going to fire. So that's pretty cool. It's pretty fast. I'll show you an example. It will definitely trigger on this sample of code, which is what we want. But there are going to be some caveats. So for instance, what if somebody says from flask.response, import set _ cookie as SC, and then they say SC username Isaac. well, that's not great. That's it's a little bit subtle, and our grep expression is not going to catch it. Another example, like what if they are actually doing it right? Our grep expression is pretty non-discriminatory. It's still going to trigger on this case. Or if they have, like they're using a code formatter or something, or they just have wonky syntax and they're multi-line, or if they've commented out the code, grep is still going to fire in all these cases. So, just to make these explicit, it's not going to handle the default arguments, imports and renames, keyword arguments in Python, having multi-line expressions, or any kind of commented out or semantically invalid code. So when we look at this, like our scoring on this input set, we basically have 1 true positive, 3 false positives, and 1 false negative, which is not great. And the question is there anything that we can use to do a little bit better? We're back in the XKCD world of, okay, I had 99 problems, I used regular expressions, now I have 100 problems. The fundamental issue, with trying to use something like grep is that code is not a string. It is really represented as a tree, right? So the first thing that the Python interpreter does when it loads in your code file is it converts it to a tree-like structure, typically called an abstract syntax tree, in order to be able to execute the code. And so I'm going to show you just a real quick demo of this open source tool that we've been working on called SymGrep, where we'll look at that specific snippet exactly. So let me know if this is not coming through. I'm going to zoom it in to make it just a little bit bigger. And we've got like a couple different examples. Some of them are good, some of them are bad. So you can see that at the start, we're like importing Flask response as R. So instead of response.setCookie, it's just going to be r.setCookie. And the general idea here is that you should be able to match the code by just kind of copying and pasting and using things that are very, very similar to the sort of code that you see. So here I've just said flask.response.setCookie, which is like the full name of this function here. And I really don't care about what's in the arguments to start. I just want to see if this is going to work. So I'm going to run it. And in fact, yes, I get a couple different examples. So the commented out code is not firing, but everywhere else where people were using this response.setCookie, it just kind of works, which is great. So it's handling this import case for us automatically. So that's pretty cool. But really what we wanted to do was set up something for our developers so that we can say, hey, this case is actually secure because you've set these flags. But this case here, like, why are you doing that, developer? Or like maybe this developer just doesn't know what's going on. So for this, like I'll come back to some of this stuff and show you some more examples later. But there's a YAML syntax that you can use to combine patterns in some Boolean expressions. So we kind of want to grab this part here and basically say, okay, as long as this is not the pattern, but the pattern looks like what we had before, and then we can give a little message that's like, hey, dev, it looks like you are not setting secure cookies. Great. So I'm going to run this, and boom. It looks like exactly what we wanted happened. So this first case here, where response.setCookie without any of those secure flags is being set, and this one where they're explicitly not being set, are both being highlighted. And this example down here is not being highlighted. So that's pretty great. But the cookie might not be named user rights. So like what if it's user rights 2, for instance? All of a sudden, boom, we're highlighting this one. So really what we want to say is, yeah, you know what? I don't actually care about any of these arguments to the set cookie call that come before. So I'm just going to put ... and let's see if that works. So boom, that actually did the right thing. And basically what we're saying, this ... operator, it'll just collect. It's kind of like the wildcard in grep. It'll just collect lists of arguments. The last thing I'll show you before we go back to the sort of best practices is, okay, what if, like, since this is Python, you can specify these keyword arguments in any order. So what if the, like secure flag was actually last, for instance? Well, that would do the same thing in Python, like, but would our rule set here still match it? And in fact, yes, the SymRep tool is aware, it's actually not language independent, it's specific to the language. And it's aware of, the fact that like, oh, there's more than one way to do this in Python. So it considers this code snippet to be semantically equivalent to the query that we have here because it understands those Python semantics. Cool. Any questions about that? We're gonna go back into some of the Flask gotchas, but I think this is a really interesting example of how we can use some relatively simple tooling in a powerful way to discover these sorts of vulnerabilities. Cool. Thanks, Ian. All right, so charging along, the next thing we're going to talk about is injection. So of course there are a bazillion different kinds of injection. The ones that we'll cover mainly are SQL injection and template injection. So SQL injection, if you know what this is, you're like, oh yes, this is so obvious. If you're not familiar with it for some reason, I would just call your attention to the fact that, hey, if you were looking at a Stack Overflow answer or reading some sort of tutorial book that had this code snippet, it looks super innocent. It doesn't look like there's anything wrong with it. But of course, the problem is, what if the query, which is coming from the user, looks like this, apostrophe space or 1 equals 1? Well, then all of a sudden, the query that the database sees is going to say like empty string or 1 equals 1, which, in case you're not familiar with SQL semantics, is going to always evaluate to true. And then instead of only the row that matched getting returned, every row is going to get returned. So this is a problem when you have, like a users table where you're trying to select the user where the username and the password matches, and you're suddenly able to bypass the matching logic. Here's another example of a gotcha inside a security framework. The most obvious recommendation here is, hey, don't use SQL, which maybe 10 years ago sounded crazy, but really object relational mappers have gotten a lot of traction, and they tend to be not vulnerable to these, with a few exceptions. Like SQL Alchemy, which is the one that people far and away use the most for Python, has a couple different escape hatches that you can use to still get raw SQL access. The second recommendation that you might hear is, well, you need to sanitize all user input. I think this is actually a fairly bad approach, to be honest, even though a lot of security people will tell you to do it, mainly because it just relies on you doing it everywhere. You have to have this strip bad characters function. It has to actually be stripping all the bad characters and like not messing with the semantics of the query, which, because your database might change versions and things, is kind of surprisingly hard to do. So the one that I like the most is basically, let's get people to let's have the developer maintain this separation between code and data by making sure that they use parameterized queries. Now, unfortunately, in my mind, in Python, parameterized queries look really similar to the string interpolation syntax. So it's a little bit subtle to understand what's going on here. But number 3 is totally different from what we saw on the previous slide. I'll flick back there in case you want to take a look at it. And what's happening in example or recommendation number 3 is that the separation between what is the SQL query and what is the data from the user is being maintained all of the way to the database. So the syntax looks very similar, but it's as if there are 2 separate packets, one with the query and one with the user data, that are going to the database. So that separation is very cleanly enforced. And in fact, requiring people to use parameterized queries is the method that's used to prevent SQL injection at scale at places like Google. I was actually in the audience at Usenix Security a couple of years ago, where Google gave a presentation about how they eliminated SQL injection at scale at Google, and this is exactly what they did. They had a compile time check that would make sure that everyone is strictly maintaining the separation by forcing them to use the parameterized query API. The other thing, of course, coming back to what will be a consistent theme throughout the presentation, is you really want to automatically enforce one of these. So if you're supposed to be using an ORM, don't let people, suddenly insert raw SQL without some sort of, reviewer from the security team being involved. So that was SQL injection. You're probably like, oh yeah, I know about SQL injection. Here's one that is very specific to the Jinja templating language, which is used both by Flask and Django. So here we've got a error handling function that's returning a template. You can see we've got these brackets inside the template, which are telling us, hey, here's exactly where we go back. So if I return render template string, what is the problem here? I will give you a minute to think about it. Well, the problem, unfortunately, is the way that render template string works. It may not be completely obvious from looking at it, but for instance, here's an example where we use Postman. We set the refer, which is of course controlled by the browser, to be curly brace 7 times 7, curly brace. And if we let the server render that, what they're going to see is 49. Okay, well that might seem harmless, but this is something that it just executes in the context of the server. So if instead of 7 times 7, we put in config, the potentially sensitive config with all of the environment secrets and everything will be dumped right out to the user. This is not great. And here's a recommendation. It's pretty simple. It's don't use render template string. There is a much safer render template which will not perform this kind of interpolation by default. And like the frustrating thing, I guess, is, hey, this is not something that is super intuitive or obvious to the user. So here's just a really quick example. This one uses a slightly more sophisticated syntax. So we talked about the ellipsis operator before, but SymGrep also has support for what are called meta variables. So I can basically say, hey, like some variable looks like this. It's some string. I don't really care what it is being formatted. And then somebody's calling this flask.render template string with that as the first argument. So here's an example of a code snippet. You can see we were creating our Flask app. I'm bringing in the template here. I'm using a string formatter on it that uses the request URL. So not the refer in this case, but the URL. And then this is triggering because we're passing that template right into the Flask render template string. And we've created a nice little message for the developers so that we can be like, hey, FYI, this is something that you probably shouldn't do. So it's actually, just to give you a little bit of context, this is a live editor, but you can run this locally in a Docker container, and there's just like a little URL that points to this config, or you can download it and run it completely offline. And we've got some binaries for brew in addition to the Docker image. So easy peasy, but again, you had to know that this was a potential issue in Flask. So it's kind of a gotcha. Here's another gotcha that comes directly from the OWASP list, which like you might have heard about before, and in which case you're like, oh, I know what's going on here. Otherwise, you're probably like, well, it seems there's this weird fourth line, but what's going on here? So in fact, XML, your reaction to this, what's the problem here? You might say, well, hey, some languages are meant to be read by humans, not by machines. Others are designed to be read by machines, not by humans, and XML solves this problem by being readable to neither. You would not be wrong, but XML has a kind of exciting feature that lets you specify any path URL essentially that can be just injected into this XML file. So if your user has control over the XML that is being injected into this file, and they're able to inject this entity tag, not only can they cause the server to render back, oh, this is the contents of some arbitrary file, but you'll notice that that file prefix means it's just an arbitrary URI. So it could be a port. You could abuse this to do port scanning of the server, be accessed, privileged access inside the local network. Not great. The also really not great news is that in Python 2, out of the box, this is a vulnerability in 2 of the 5 built-in Python libraries. In Python 3, it was fortunately fixed, but there are a bunch of other denial of service vulnerabilities that all 5 across both Python 2 and Python 3 of the XML parser libraries are vulnerable to. So that's kind of depressing, to be honest. It's so bad that the official docs actually recommend, oh, if you are parsing XML that comes from an untrusted source, well, recommendation 1 here might be don't use XML, but if you are using it, you probably have to be. Recommendation 2 might be, well, maybe you could just disable that XXE thing. Turns out that's not an option as far as I can tell in any of the Python libraries. So the official Python docs actually tell you, hey, just use a different library, which has a great name, diffused XML. And then, of course, again, automatically checking to make sure you're not using that vulnerable library. And for the sake of time, I won't show you the pattern for that, but it's what you'd expect. Anytime somebody does import XML, you should trigger on that and say, hey, is there really a reason not to prefer this other library, which is safe by default? So the next one, OWASP 7, is cross-site scripting. This one, you're probably super familiar with. And I guess the interesting thing, if you're already familiar with cross-site scripting, is that there's only 1 vulnerability in this code snippet, not 2. So I'll give you a second to look over this little bit of HTML, which is going to be rendered using Jinja, the built-in template renderer for both Flask and Django. Well, Django actually has a Django template language, which is based on Jinja, but it's quite similar. So the problem here is app name is actually going to be escaped. It's going to be escaped in the HTML context. It's going to be totally fine, but value is not. So value looks like something like this: on mouse over equals alert XSS plus the document cookie. Boom, that's XSS in our application. And if you took the time to go and read the docs, you would see, okay, well, Flask does automatically configure Jinja to automatically escape values. That's great. But there's some caveats. The second caveat there is these unquoted attributes. So this escaping does not apply to the values of HTML attributes. And in fact, there are a couple of other gotchas. So there's our gotchas again. If your template file doesn't have an HTML extension or an XHTML extension, the escaping will suddenly be turned off. So if you're using like .html2 or like .jsx for some reason, you won't get the benefit of the default escaping. And just to give you a real concrete example of that, so this means that basically if we have an application that looks like this, so /safe, we're returning render template with safe.html, and we're echoing back what was in the request arguments, that's fine. But if we change the name of that template to unsafe.txt, suddenly not fine. So in fact, anything outside of just those two safe extension names will not be safe. So this is kind of great. This is a real, like sharp edge inside the framework that I think really ought to be fixed at the framework level, because it's really non-intuitive. And in fact, we discovered this at R2C because one of our team members was developing a Flask application, and was reading the documentation and was like, "What? How does this happen?" So the recommendations here are, well, first off, it's actually probably best to just use a front-end framework, like for instance React.js, which is just less vulnerable to XSS. And I'll talk about this a little bit more later on. I know there's a lot of framework fatigue in the JavaScript world, but React.js, which was made by Facebook, actually deserves a special shout out because the Facebook security team specifically put a lot of design time into it to make sure that XSS was as close to as impossible as could be made. And it's a real standout in terms of its invulnerability to XSS attacks. Obviously, you always want to use HTML extensions for templates, given what you just learned. Another great thing you can do is just to set a content security policy for your application. We don't have time to really talk about that in detail, but it's a pretty robust, it's a little bit of a mitigation rather than a principled defense, but it can prevent a lot of XSS attacks from actually being exploitable, even if you do screw up. And another great recommendation is Google actually was like so annoyed by these problems, they created a library specifically to address this and some other Flask security issues. So it's pretty easy to use. But basically, again, whichever one of these things that you're doing, you want to do it in as consistent and straightforward of a way as possible, just getting it automatically enforced. So we've got a few more, to talk about insecure deserialization. If you're not familiar with the Python pickle module, it lets you load and serialize data to disk. If you do that with user data, and the user data happens to look like this is a nice reverse shell that's basically going to open up a connection to Evil Server, and it'll be as if the owner of evilserver.com has SSH'd into your server. So that's great. You would think that this would be like very unlikely, but it seems to be so common that Metasploit actually has a payload for it. And this is also a problem for many other formats. So for instance, versions of PyYAML into super recently the default.load method, if you were loading data that was supplied by the user, it would suscept you to arbitrary code execution. So, it just turns out that the easiest way to make a serialization and deserialization framework is to allow for arbitrary code execution. So any kind of, serialization toolkit you're using, you should suspect that it's probably going to be vulnerable to this. And the great news is that we haven't even gotten to talk about everything. So we talked about the top 10 for web apps, but we just had somebody who actually worked on the OWASP top 10 definition for APIs come and give a talk at R2C last month. So if you've been sitting through the presentation and you've been like, oh yeah, well, all this HTML stuff, I don't have to worry about that because it's JSON in, JSON out for our application. We're a pure API. There's a whole new set that OWASP has produced for them, which are pretty great. So I'll give you one quick example of that. So here's a pattern that you might see. We've got a create user function. Turns out the fields in the request form have the same names as the user object fields. So we're just using this double $ operator in Python. If you're not familiar with it, basically, if request.form has a field named name and the user object has a field named name, it'll just match up those two fields for us automatically. So this is great. Developers being lazy, less code, seems fine. Problem is that, what if request.form expands into a field that's like is admin, for instance, which the user, that was never present in the form that we sent to the user, but suddenly we're allowed to set it if we just guess at what those field names are in this mass assignment. So again, I'll just give you a quick example of how you can detect this sort of thing automatically. So here's a pattern. We're actually using an OR syntax in this SimGrep example, but we've basically got some model. We're creating it with something that comes directly from the request, or we might be updating it with something that comes from the request, and then we don't really care about what comes after that, but we're just saving that object. So here you can see some examples of both of those things triggering and the message that we might display to the user in that case. So, pretty subtle, pretty easy to do. And the real takeaway here is like anytime you're writing in a framework, even one that does a pretty good job out of the box like Flask or Django, it's just full of gotchas. And as somebody who's just trying to keep things sane from a security perspective, you might be tempted to throw in the towel. So that's why the final part of the presentation is really about how do we automate security in a first-class way. And so there are a bunch of different tools that people have developed for this. There's formal methods, there's letting people poke at it, aka bug bounties, which is actually a great strategy. The two that I'm going to talk about at the end of the presentation here are secure by design languages and frameworks and static analysis tools. So, we talked about some frameworks already, right? You can avoid SQL injection for the most part if you use SQL Alchemy. You can avoid XSS for the most part if you use React. You can avoid XML vulnerabilities if you use this diffused XML thing. We didn't have time to talk about JWT tokens, but that's a way to avoid a lot of CSRF vulnerabilities. And the Google Building Secure and Reliable Systems book that just came out is a big fan of this idea of, hey, let's fix these things at the framework level as much as possible, because when we fix it at the framework level, now you're removing it from the entire application space. Like every application that this framework used, that vulnerability is no longer present. So this is a specific call out to how Google deals with SQL injection. It's done at the framework level. And what makes some frameworks better than others? So coming back to that debug equals true example, which fortunately in the very latest versions of Flask, there's now a pin number that you have to guess in order to get arbitrary code execution. But really, like what they ought to do instead of just saying don't use this in a production environment is say, hey, don't use this in a production environment or you're going to get hacked. But an even better thing to do, the best thing I think would be to say, hey, this is by default, it's just impossible to enable this like weird arbitrary code execution for debug functionality. But because you're running with this super scary, dangerous flag, we're going to let you do that, but we're just going to complain about it all the time in the logs. So another bad example of this, to be honest, in Flask is that render template string versus render template, right? Pop quiz, which one was the one that had the vulnerability? It's not obvious at all from just looking at the names of the functions. And a good example of this is in React.js. They renamed the inner HTML method, which came from jQuery, to be dangerously set inner HTML. And they made that pretty much the only function that could actually inject arbitrary HTML into the DOM, which is great because now, like anytime your developer's using this, they're like, what? Why am I doing something dangerously? And it's easy for the security reviewer to spot it. So in fact, I would highly recommend the new Google book, which you can download for free. They actually have a whole section about those OWASP top 10 vulnerabilities and what the specific framework hardening measures Google has taken to fix each of them are, which is great. And we talked about Flask Talisman a little bit. So if you're specifically using Flask, you should definitely do that. It sets a lot of good defaults for you automatically. But the fundamental takeaways are, look, if the attacker knows more about your framework than you do, you're going to have bad time. So you're going to at some point have to read the docs or at least use some sort of tooling that has read those docs for you in a comprehensive way. That's kind of what we're trying to do, by making it easier to do the sort of custom static analysis that people might be interested with grep by providing open source tools like SymGrep. Yeah, so there's more I can say. This is a much longer presentation, but I know we got started a little late, and I just want to be respectful of the next presenter's time. So happy to take questions, and we'd absolutely love it. If we could get some feedback on, was this too fast? Was it too slow? Are there other things that should have been covered? So there's a super short survey link here at the bottom.
Very cool. I'll make sure to share the survey link in the meetup. And
Awesome.
I don't. There are no questions in the chat, either in Slack or on YouTube. So I guess we'll. Well,
Yeah, I know you're managing the stream, but any questions that popped into your mind, Ian? I don't know if you've used much Flask in the past.
I've used Zero Flask, but
Oh,
I
okay.
I really appreciate your approach. I'm one of those guys who usually preaches frameworks and static analysis in pipelines. So
Hmm.
this is you're preaching to the choir here.
I'm glad to hear it. I'm glad to hear it. Yeah, I was, the Google book came out just pretty recently, and it was kind of cool to see them just putting a lot of detailed content out there talking about how valuable that's been for just eradicating whole classes of things and making it so you don't have to worry about it.
Yes, indeed. Well, if no one has any questions, thank you very much for your excellent presentation, and I'll make sure to chop up the videos and provide the slides and the feedback link into the meetup. And we thank you very much for your time. Thanks for presenting at
Absolutely.
OWASP.
Yeah, it was a pleasure, Ian. Thank you so much for hosting.
Thank you.
Oh, yes, I can. Actually, I am. Let me just check if I have everything set up. I think I do have everything set up. So this is it, right? Just on the Hangout, and there's nothing else, right? Mm-hmm.
I have YouTube and Slack, but there's it's I if you if yeah it's kind of this is my first real stream, so I'm a
Okay.
little disorganized if you don't mind.
No, no, that's fine.
Uh,
No, I was just checking if there's anything else beyond this that I was missing.
oh
So if
no,
I'm not, then yeah, we can get started because yeah.
yeah, I just let me just make sure to get the Hangout properly situated, and then we should be good to go.
Yeah,
So just one moment.
no problem. Um, I'm just looking for. where I can share my screen. It doesn't seem to be an option here. Yes, yeah. No, unfortunately not. Yeah, I'm looking for it as well. I didn't find anything. No, that's yeah, it is. In fact, I'm also surprised by this because I'm not seeing, yeah, I'm not seeing anything that says, share screen or whatever. And I use Hangouts every day at work, so it's kind of weird. But Mm. Oh, okay. Sure. Yeah. Yeah. 1 second. Yeah. Yeah. 1 second. Let me just get to that. I'll shoot you a link right now. Uh, 1 second. OWASP Seattle. Let me just call it WASP Seattle. It's just easier. Because it gives some random name, some sort. Yeah. Uh, that's okay. I'm just sending you an email now, and I can also send you a link on this very chat. Hold on. I think that's the one. I'm just going to be on that. I'm going to get off this, okay? Yeah. Yeah. I think we're good.
Yep, we look good. Just one moment while I get the Hangout window situated.
Okay. Okay. Do you mind just sharing the YouTube live link? I'll just tweet about it before we get started. Oh, actually, let me just pick it up from the meetup thing. Yeah, I got it. Yeah. Looks like it. Okay. Yes, I do. I do.
Yeah,
Okay.
why don't you go ahead and start, and I'll make sure to adjust it so that it looks correct. And
Yeah, 1 second. I'm presenting my screen. Can you see it?
I can. Just let me make it look ideal in the presentation view, and then we'll be good to go. All right,
All right.
that looks about right. Good.
Okay. Do you want to wait a couple of minutes or do we get started? Okay. That's fine, maybe. I can get started. No problem. All right, so let's go. Thanks, Ian. Thanks for setting this up, and really happy to be here speaking at OWASP Seattle. Although we're doing it in a slightly different model than I think a lot of us are used to. We're doing it virtually, and I hope everyone's staying safe and self-isolating and all of that stuff. So I'm here to talk about something that's been an area of focus for a while now, which is managing secrets on the cloud. And so I want to give a multiple perspectives. This is a short talk, so I'm going to try and optimize for time, but uh, give a different perspective of secrets in different cloud environments, AWS, Azure. Although there are lots of similarities and they've kind of converged on a bunch of similarities, I'm just going to try and explore some unifying factors and some maybe divergence factors as well. So with that, a quick introduction of myself. My name is Abhay. I run an application security company out in the Bay Area called We45. So we are all in all application security. We don't do anything else but AppSec. So we kind of break stuff, consult on stuff all day long. We do a lot of training as well. In fact, we train Black Hat and multiple events, OWASP events all over the globe. Myself, I've also been involved in a lot of open source projects, some interesting open source projects that you may want to check out. One is called Threat Playbook. In fact, we're making a lot of changes to Threat Playbook this month. Threat Playbook is an automated threat modeling as code framework that we want to, so you can run threat models like you can do DevOps. That's the idea. So with Threat Playbook, so that's Threat Playbook for you. We also have another project around serverless apps, which is called DVFAS, or Damn Vulnerable Functions as a Service. That's another framework that we created for serverless applications as well. Now, obviously, I'm sure a lot of you are, at home and probably want to learn something new. So if you're interested, we do a lot of remote training as well. So if you're interested, just check it out. This is going to be in the slides as well, so I'm not going to get into this too much. Community initiatives, we do have a YouTube channel. Please consider following us, and of course, blogs and stuff that we do and talks. Now, before I get started, I do have a quick prayer that I'm going to say to the demo gods. I do have a couple of live demos, and live demos are always tricky. For those of you interested, you can also follow us on Twitter. The Twitter links are at the bottom. You can check it out and follow us on Twitter if you're interested in content like the one I'm talking about today. So let's get started with our presentation today. And of course, at the end of the presentation, I'll be happy to take questions. I'm not on the YouTube link, so I'm not going to be able to see the questions beforehand. So maybe at the end of the session, we can probably do questions and figure out if anybody has any other comments, clarifications if they need. So let's get started with our agenda for today. So I'm just going to get right into it because there is not too much time. So I'm going to get started with the whole, the ubiquity of secrets and the whole concept that secrets are expanding like crazy today, right? So we have secrets that are becoming, you have a scenario where your average application has a lot more secrets that it's dealing with and sensitive data that it's dealing with than ever before, right? So you have API tokens, you have passwords, you have keys, you have so many things that you need to handle. So let's say your application is talking to 5 other applications, and there's a very good chance that it already is. You have secrets related to all of those other applications. And of course, you have secrets related to other services like email maybe, or some other messaging gateway. You have secrets all over the place. So let's look at some of the challenges with that. And of course, secrets in the cloud, I'm going to get right into it and figure out, look at the different services that give you, secrets services on the cloud, secret management services on the cloud. And then finally, we look at cryptographic services on the cloud. Now, this talk is not going to be too much about, which algorithm is better. It's not going to be too much of a heavy crypto talk. It's more about, hey, which are the libraries that are out there that can help you do this stuff better? Which are the tools that are out there? What are the services that the cloud providers offer? I'm essentially sticking to AWS and Azure because I'm not as exposed to Google Cloud as these two. Again, a little bit more AWS than Azure as well. So I'm going to be sticking to that. So that's what this talk is going to be largely about. It's going to be looking at these type of services on the cloud and largely protecting data at rest, right? So we're largely going to be looking at protecting data that's stored somewhere, especially on the cloud or in databases, or so even not necessarily on the cloud, but protected some with a cloud secret management or cryptographic service. So that's essentially what we'll be looking at today. Now, secrets, like I said, have become quite ubiquitous. An average application, I'm sure, as a lot of you in the room write code or probably part of an engineering team, probably an extended part of an engineering team, you would have probably seen that this is kind of blown up a little bit, right? In the sense that you have so many different secrets today. You have API keys, you have tokens, you have encryption keys. And of course, the more number of services your applications are talking to, the more number of secrets that you typically have to deal with, right? So you're seeing that secret management is becoming more and more critical as we go along, especially when we get to distributed systems. So let's say you're running a Kubernetes cluster, or let's say you're running some workloads on the cloud, or let's say you're running some serverless applications. All of these have a ton of secrets. You have a lot of secrets that you typically need to manage. And of course, a lot of these secrets tend to get exposed from time to time as well. And sometimes, I mean, all of us look at these exposures and we say, hey, you know what, I would never do something this stupid, right? And it looks to us that this is stupid, but you'll be surprised how many times all of us who are even very security minded make these kind of mistakes, because again, have a lot to deal with. We have a lot of secrets to protect. We have a lot of sensitive information that we're dealing with all the time. So things like this tend to happen from time to time. So you might have somebody who's committing an environment variable to code. You might have somebody who is committing private keys or API tokens to their GitHub repos. You might, let's say you're using Terraform or something like that. All of us who use Terraform or other infrastructure as code tools, we might have passwords hard-coded in Terraforms, and then of course Terraform scripts, and that would make its way into GitHub repos or any other source control repo within the organization, hopefully not outside the organization, but sometimes that happens as well. So secrets are a pretty big part of our daily existence. We have to handle them. Of course, we need to handle them much better than we do. And we need to understand that this is a growing problem, right? Especially with today, with distributed apps, with the stack that is also expanding quite a bit. So we're looking at so today we have single purpose things for everything. So let's say I want to run a database. I might be going with something like a MySQL, but let's say I want to add some search capability on top of it. I might have to index all of that data to an Elasticsearch or something else. So today we are expanding the stack quite extensively as well. So that is a challenge, and that also increases secrets. So secrets, that's one of the challenges. So secrets are exponential in distributed apps. You have a lot of different types of secrets. Whatever you do typically involves handling secrets. So, and more secrets leads to potentially more secret sprawl. And secret sprawl could be secrets in code, secrets in all of these places. So in code, of course, in scripts, in build scripts, in infrastructure as code scripts. It could be in a config file. It could be in an environment variable file that you've just committed somewhere. All of this is typically what we look at as secret sprawl. And the larger that sprawl gets, the more complicated it is, obviously, for you to secure. So one of the things that you might have realized by now, as we're already talking about this, is that centralization of secrets is going to be the name of the game. And one of the good things that we're going to be looking at is that all of the services that I'm going to be talking about and demoing help you do that, right? They help you centralize. And that's one of the key aspects of ensuring that your secrets are protected to a large extent. So it's just like asset management to a certain extent, where if you don't know where your assets are all sprawled all over the place, it's very hard to protect it. Same thing happens with secrets. If you don't know where your secrets are, or you're not able to identify, or you're not able to identify potential areas of exposure, you're obviously going to be that much less in the know. Now, common patterns that a lot of us use when we look at secrets is environment variables, right? A lot of us do this. And this is, I'm not even saying that this is altogether bad. Yes, there is a certain issue with environment variables. Obviously, we all know that if somebody is able to compromise the server or that environment that is running that application, then your environment variables are hosted as well. So which means you get pretty much get access to the environment variables as well. So you typically, I've seen folks just use environment variables, especially when they're using containerized workloads. Environment variables are the name of the game. Of course, you might, let's say you're a little bit more security minded, you might end up using key rings and keychain. Again, it's okay, but then again, you still have a lot of issues trying to protect key rings and keychains. Access control is a problem. Auditability is a problem. Unless you're a Linux whiz and you really do a great job in terms of auditing it or ensuring that it has logs, and of course shipping those logs off to centralized log management, it's tough to manage stuff in the keyring and keychain. Notwithstanding that, a lot of the Linux kernel issues, a lot of Linux keyring implementations are vulnerable, right? So we've seen that Linux keyrings and keychains on Unix systems have a lot of security flaws that have been associated with them over the years. So that is something that you see. And of course, we have GPG, right? And I'm sure a lot of you realize that GPG is not something you want to use. GPG is hard to work with. So we have some issues with environment variables. One, of course, it's a complete compromise if your server is compromised. Let's say your application has an injection flaw or a command injection or a template injection or a server-side request forgery. We've seen that environment variables can be compromised completely, right? If you're working with keyrings, it's definitely better than using environment variables, but it's still it's iffy in terms of trying to protect it. It's hard to protect keyrings because of access control, and especially when you're working with containers, it becomes a little bit more complicated. And of course, GPG, right? Let's face it, you really don't want to use GPG because it's hard. You need to generate it, you need to load it. It's doable, definitely. I'm not saying it's not, but it is a bit of work. Definitely something that you may want to reconsider. So let's just do a quick offensive demo and then look at how easy it is for some of these things to get compromised. So the previous speaker spoke about template injection. I'm going to try and showcase a template injection right here. Just give me a sec. So this, I'm just going to load one of our labs and then I'll just show you how template injection makes it so easy for us to compromise this particular thing. So this is our lab environment for our training. So this is one of our Kubernetes labs. So I'm going to use this to actually run a Kubernetes cluster and compromise it with template injection. So I'm just going to run. So I've already installed some Kubernetes dependencies. I'm just going to set up the final cluster. I'm using kubeadm to set up the cluster. So it's just going to quickly set up the cluster and get started with actually running that cluster. So we are just, I'm just going to wait a few minutes for this to happen. It's going to be running a Kubernetes cluster on my lab machine. And once I'm done with this, what I'm going to do is I'm going to also exploit a particular flaw with this Kubernetes cluster, right? So you can see that the Kubernetes cluster is loading, and it should take a few more seconds for us to actually deploy stuff on this cluster, right? So it's just waiting for all the containers to spin up. So this is just a single node cluster. This is not a large Kubernetes cluster or anything like that. It's just a single node cluster that helps me actually just demo some stuff for all of you. So I'm just going to run my vulnerable app that's vulnerable to template injection. So give me a sec. ctl apply f template injection manifest. Yeah. So you'll see that we are now running this kubectl get nodes pods cdc. So we are, it's still spinning up. So I think we're going to wait a few more seconds for this to happen. Now, once it's done, we're actually going to exploit this, right? So we're going to exploit this vulnerability, and we're going to look at how easy it is for us to actually steal secrets from our application. So our steal environment, dump environment variables from our running application, right? So this is vulnerable to a template injection flaw. Now, a template injection flaw essentially is where you use a server-side templating system. In this case, we're using Ginger 2, which is essentially what the previous speaker spoke about. So I'm glad that there's some context to that already for people who attended that talk. So essentially what happens is that we mix in user data with a dynamically rendered template. And if the user data happens to, have some kind of an impact on the backend Python interpreter, you will see that it executes just like any other Python program and causes a problem. So let's actually run this now that all of our deployment is running. So I'm just going to run it on localhost, and this is running on localhost 32345. That's the port. I'm just going to run it on localhost 32345 / not found page is equal to something. Now, when it says something, what I'm looking for is essentially this URL parameter is just going to be echoed on screen here. So it says something page you're looking for cannot be found. But now let us say I actually load some kind of a templating system here, a templating variable here, something that makes sense to the backend templating system. So I say 7 into 7, right? So that obviously should evaluate to, hopefully, it should multiply and evaluate as 49. So it says, hey, this 49 page you're looking for cannot be found, which means that my template injection is probably going to work. Now it's a Flask application, so if I go ahead and do config.items, I should be able to pull the Flask config.items right from the back. So if I just do config.items, this is going to essentially pull out the dictionary that contains all the config objects of that backend Flask application. So if I do this, I think I need to double quote this. Sorry about that. Let me just see if this works. Yeah. So as you can see that we've been able to dump the environment variables and the config objects for that backend Flask application, and you'll see that we actually got the MySQL password. We've got the MySQL connection string here. We have, I think, some other stuff as well, some other HMAC password that we need to generate the JSON web token as well. I think I'm not able to see it, but it's there somewhere. The idea here is that you should be able to dump anything from the backend. So with template injection, not only do you get access to this kind of stuff, but you can actually extend that access to pretty much anything. You can get shell on the box and then start expanding your access on the local network. So this attack actually leads to a full-fledged Kubernetes cluster exploit. I'm not going to demo the cluster exploit because that's not what we're talking about right now. But just to give you an idea, this is as simple as it can get when it comes to compromising the secrets that you have in a distributed application that you're running in a Kubernetes or some other kind of environment, especially on the cloud, wherever. In fact, even with serverless, let's say your serverless function is vulnerable to, let's say, one of these flaws, or especially with AWS, all your secrets, your AWS access key ID and secrets are in the Lambda's environment variables. And while this is a pattern, and yes, you do have to store something in the environment variable, this can lead to a complete compromise depending upon what kind of privileges your Lambda has on your AWS account. So the other challenge with using environment variables or all of these kind of techniques to protect your secrets is that access control is hard, right? You can't really do much access control because the user who's running your application is obviously going to have access to those variables, and them having access to those variables itself becomes a challenge. And accountability is extremely difficult. Now, remember, one of the things that you have to realize is that you obviously can't always prevent stuff from happening. So you should be able to log stuff, monitor stuff, and see whether you can attribute actions to a particular user or to a particular compromise or an event or something like that. Accountability in this case, especially when you're using environment variables, and if you're not using something which is a little more centralized and meant for that purpose, you will see that it becomes very difficult to audit and account for those kind of issues, or even get some kind of a trail on what's happened there. And of course, it does not really provide for rotation, rekeying, and all of that stuff. Now, if you are in a highly regulated environment, so let's say you have to be compliant with PCI, and of course, let's say FINRA or some other compliance requirements, you need to not only do good secrets management and key management, you also need to ensure that you do key rotation and rekeying. This is a good practice in general, but if you are definitely you need to be compliant with these standards, then this is not even a good practice. This is a mandate. You need to do this. So none of these approaches give you the possibility of doing that. And that's the big problem with some of these more native approaches to handling secrets. So secret sprawl, like I said, we can see this all over the place. We've seen this on source control. You can see this all across your Git repos. In fact, using something like Talisman or something like that, you should be able to find a lot of these secrets in your Git repos. Hard-coded secrets in your application, of course, and in your database. Let's say you're doing plain text. That's, of course, a slightly different problem. But this could be in a lot of these places. And one thing that it's becoming much more rampant in is in terms of CI/CD tools, right? So let's say you're using Jenkins, or let's say you're using GitHub Actions or Terraform or what have you. You will see that a lot of secrets make their way into these build scripts and these infrastructure as code tools. This is a huge problem because this tends to have secrets that are quite large impact in terms of when they get compromised. So, and of course, you should always remember that there is a possibility of internal compromise, right? It's not only that some bad guy from the outside is going to come and compromise your application. Someone can potentially read your logs or read all of this stuff and then do something adverse with it. So that's something that you have to always keep in mind when you're looking at secret sprawl, because a lot of the insider threat is ignored when we're looking at secret sprawl as well. So one of the good things that has happened, especially in secrets, especially in terms of secrets management over the last 7 or 8 years, is that we've seen the emergence of a lot of products that are quite mature in dealing with this. So first of all, if you're doing secrets management on-prem or even on Kubernetes or something like that, I would really recommend using HashiCorp Vault. And that's really phenomenal tool because it's open source. And one of the cool things is that its open source tooling is really powerful and quite capable to work for a lot of use cases, unless you're a massive enterprise, in which case you might need the enterprise variant. But Vault gives you a lot of different tooling options. It gives you secrets management, it gives you encryption, it gives you dynamic secrets, it gives you auditability, it gives you all of that stuff. So Vault is one of those things that I think really pushed the envelope forward in terms of how good a secrets management tool can be. And I think a lot of the cloud providers have taken a leaf out of that, although I'm sure they may not admit it as much, but they've definitely taken leaf out of how Vault has architected the way it does, anything related to secrets and cryptography, and of course dynamic secrets and so on. So secrets management from cloud providers, I would say, is a great step forward because they've really thought about this in a very comprehensive way. All cloud providers, at least the three big ones, have really put in a lot of thought into this, so which is great. And I'm going to be talking about that for the rest of the session from here on out. All right. So when you look at secrets management for the cloud, I'm going to be focusing on three. I know there are other cloud providers as well, but I have not worked with them, so I have no idea as to what they do in terms of secrets. But these three I have had some experience with, more so AWS than any other. But with AWS itself, you do have different services that handle secrets. So AWS has the kind of a foundational service, which you would call the KMS, or the key management service. Right, the key management service is kind of the bedrock service for all other services, right? So if you want to do encryption of a RDS instance, you want to do encryption of S3, you want to do encryption of anything in AWS, you are using this bedrock service, which is key management service, to actually do that. So that's one of those services. It's a service of service, right? So it's essentially kind of a service that does encryption and handles encryption and key management for all other AWS services. I think its footprint is across, I would say, at least 90% plus of the AWS services. So if you're using any AWS service and you want to do some kind of encryption as part of the service, you are under the hood using Amazon KMS. So that's one of the things you should keep in mind when you're using that. And KMS is what you would typically use to do encryption, right? So when you want to, so let's say you're storing credit card numbers or social security numbers, or let's say you're storing some healthcare records or whatever it is, you want to encrypt that. That's when you would typically invoke a KMS, right? Because it provides for key management, it provides for encryption keys, all of that stuff. So that's something that you should keep in mind when you're using KMS. KMS is not a secret management tool. It's a encryption service or a cryptographic service. It's essentially meant to do cryptography. But AWS does have two other services that do secret management. One is the parameter store from the AWS Systems Manager, also called SSM. And you also have a dedicated secrets manager service from AWS called AWS Secrets Manager. Now, the difference between these two services is that Secrets Manager is a little bit more driven towards only maintaining secrets, whereas parameter store, you can store any key value pair. So you can store any key value pair, whether it's secret or not. If you specify that as a secret, that's when it is stored as a secret value. Otherwise, it's just stored as a plain text parameter. Now, parameter store, the big difference between that and Secrets Manager is that it's free, right? Parameter store, I think up to a certain size or number of parameters, it's free. Whereas Secrets Manager, I think, costs you 40 cents per secret. I'm not 100% sure on the values, but it does cost you per secret. But the cool thing about Secrets Manager is that it gives you rotation capabilities. It gives you, I think it also does some dynamic secrets generation as well. So if you want to generate a secret dynamically for your service, Secrets Manager gives you that ability to do so. Whereas parameter store is more for, hey, I have this password, I want to store this as a secure value, as a secure key value pair. That's when you would typically use parameter store. Most of us, in fact, I typically only end up using parameter store. Very few cases in which I need to use Secrets Manager. Now, with Azure, you have Key Vault, right? Now, Azure's Key Vault is again a massive unifying service. Same with Google's KMS as well. So the service provides for not only encryption, but it's a single service that does encryption, it does secrets, it does certificates, it does access policies, it does everything related to secrets or potentially sensitive data sets and cryptography for Azure. And I think the same orientation has been applied to the Google KMS as well. So Azure Key Vault gives you the same kind of a thing, same kind of an approach. With Azure Key Vault, one of the things you can do is also expand. Let us say you want something backed by a hardware security module. I think you have a premium scenario where you can use Azure Key Vault backed by an HSM. Most AWS also has an HSM service, but I think it's a separate service. It's not bundled as part of the KMS and parameter store. But Azure, you do have the ability to either go for the software-backed service or the HSM hardware-backed service, which is obviously a little bit more expensive than the standard service. Again, with Azure and Google, you can do the same things. You can generate keys. Again, there are different types of keys, and I'm going to get into that when we get into secrets, but when we get into cryptography, but you can generate keys, you can do key value pair secret stores, you can do all of that stuff. You can also store certificates and, of course, dictate access policies and audit policies for that. When it comes to Kubernetes, it's not as straightforward because Kubernetes does not really provide any kind of secret service by itself, right? So Kubernetes does have, I want to say, an experimental encryption API, but I don't personally see anybody using it all that much. I see that most people who run a Kubernetes cluster work with other tools, right? For instance, the most popular tool that I would work with the Kubernetes cluster is HashiCorp Vault, because it can now, of course, they have much tighter integrations with Kubernetes, and they have a lot more services that they provide than the standard Kubernetes encryption service that they do. So Kubernetes you would typically use with either their encryption services, which is rare. I'm not seeing too many people using that. HashiCorp Vault is, again, the more popular service. Until about 3 months ago, this was a very hacky way to do things with Vault, but I think Vault now has released a bunch of resources and storage interfaces for Kubernetes, which means it's much easier to get up and running on Vault. In fact, in a lot of our trainings, we talk about how you can seamlessly integrate Vault into Kubernetes and stuff like that. Of course, you also have some smaller tools called Seal Secrets, which is a GitOps workflow. So you can get started with something like, let's say you have a secret, you want to commit that to Git, and you still want to load that in Kubernetes. You can encrypt it at source and then load that, inject that into Kubernetes. Kind of nice tool, actually. In fact, we showcase that in a lot of our trainings as well. There's another one called Camus, which has been built, I think, last year. This also has an interesting premise. It's like encrypted until the application that needs it uses it. So until the point the application actually uses that secret, it is encrypted, right? So that is the point of Canvas. In most other cases, including Vault, once the secret is injected into the container that is running on Kubernetes, the secret is in plain text, right? The secret is accessed in plain text. Whereas with Camus, the idea is that the secret is encrypted until use. So they have a different approach to this. It's again on GitHub. Most of these projects you can find GitHub links and references, and I'll try and post them probably at the end of my slide deck as well. I've not done it currently, but I'll do it. So a quick primer on secrets and sensitive information. Remember that secrets are different from sensitive information. Now, secrets are typically passwords and all of this stuff. You access them as key value pairs. Now, sensitive information is typically data that pertains to your customer or your application that you want to keep secure or confidential, right? So you would typically use secrets like an encryption key to store or maintain your sensitive information. So secrets are typically accessed as a key value pattern, but sensitive information is accessed usually with a different pattern. You're typically accessing it through the application or by your application itself. So that's the slight difference. Although both are backed by encryption, both are backed by cryptographic algorithms, you would still see that secrets are accessed differently, are stored differently, and maybe even parameterized differently than sensitive information that you want to protect and access from that point. So let's start with some simple principles of good secret management, and then we look at what are the different cloud providers provide for this. So one of the things that you need to provide in terms of good secrets management is version of that particular secret. So let's say you have a password called password. Of course, it's a horrible password, but nevertheless, just for the sake of the example, let's call this password password. And let's say you want to change that, and you store that as a secret. You want to change that value to, let's say, password 123. Now that can be version controlled, which means that you can have n number of versions of that particular secret. So every time that secret is edited, you create a new version. Now all of the cloud providers help you do that. They do have versioning that is built in. They have, I think in some cases you might have to turn it on explicitly, but in most cases, I think it comes in default out of the box. AWS, I think, gives you default out of the box. Azure gives you default out of the box. So once you start managing your secret, instead of creating new secret referencing IDs, you're just editing the same secret and you're generating newer versions of that secret, which means that at any given point in time, let's say your application has not fully migrated to the new secret. If you want to still access V1 of the secret, you should be able to access V1 of that particular secret. So that's something that you should think about when you're implementing some kind of secret management for your own applications. Now, any good secrets management solution should provide access control, right? Now, access control is very important from the perspective of, hey, who can access that secret, who can read that secret, who can write that secret, who can delete that secret, who can edit that secret, who can edit the metadata pertaining to that secret. All of this is typically considerations for access control, right? So you typically see those kind of considerations becoming very important because you want to be able to restrict access based on access control. So let's say let's say if your application is popped and somebody compromises your application, I should not be able to compromise all your secrets. I should only be, worst case, at the very worst, be able to compromise only those secrets scoped to that application and not your entire secret store. So access control is very, very important when it comes to secrets. So please keep that in mind. And access control, when I say access control, it's not only read and, of course, write. It's also things like metadata. It's also things like delete. It's also things like update the metadata itself. There are lots of different services that you need to account for in terms of access control. One of the things you should be able to do, especially with the cloud, since they do provide a unifying IAM implementation, is that this should become much more achievable. In fact, in HashiCorp Vault as well, you can use HCL, which is their DSL for configuration. It's called HashiCorp configuration language, to be able to set up access control parameters for your secret. So you can say that, hey, this secret can only be accessed by this token to do read of the secret. That this particular application cannot even write secrets, cannot make an edit, or can't modify a secret. The other thing that is very important when it comes to secrets is audit trails, right? Now, you want to be able to identify who's accessed the secret, when it has been accessed, what kind of access has happened. In fact, I don't know how many of you have seen the the AWS preventing credential compromise talk from last year at OWASP. I want to say OWASP AppSec California, and I think there was a previous presentation of Black Hat. Now, this essentially largely based itself on audit trails, which means that based on the way the services were being invoked, the API was being invoked, you were able to identify that, hey, this seems to be someone outside of our network trying to, or outside of our trusted environment trying to access our secret or our AWS service, which means that this could be a compromised token, AWS token, which means we have to remove it from circulation. So audit trails are very important because you can identify anomalies based on these audit trails. So that's something that you definitely have to keep in mind. Of course, key rotation, you should be able to rotate the underlying key. This is usually possible in most services. I don't think Parameter Store allows for this in AWS, but Azure and Secrets Manager and I think Google KMS allows for these as well. So handling security exceptions. Now, one of the things you can do, especially for secrets, is have log analytics for each secret or CloudTrail. So if you're using AWS, you use CloudTrail. But if you're using Azure log analytics, you can always ensure that you have all of these secret events. So read secret, write, all of that stuff. All of the API calls related to that secrets management service can be logged as part of these API logging or monitoring service. And you can catch anomalies. So let's say you have an IP address. So let's say you have an EC2, bunch of EC2 servers that are accessing your secret. If a request comes in for that secret from outside these EC2 IP addresses, you probably know that that may be a compromised service that somebody is exfiltrated and using it from their IP address, which means that you can capture that and probably disable that API key or that Amazon access key or that service. That's something you can do. You can also do tag-based params where you can tag a particular set of secrets and say that, hey, this is, you need to, every time you request the secret, you need to tag it with this. If I don't see the tag, it may be an anomaly. So that's something you can do. And of course, with the APIs that all of these cloud providers give you, you can actually just push all these anomalies to a asynchronous source like Slack, where you can actually investigate after that. So that's something that you can definitely do. I'm going to quickly go through cryptographic services. Now, all of these cloud providers give you access to these cryptographic services, which means that they generate strong keys, they rotate. You have ability to automatically rotate or manually rotate keys. They give you very detailed access control parameters. I'm going to show you a demo of this in a little bit. So in the event that you may not have understood this whole segment, we're going to look at that. And of course, gives you audit trails and something called envelope encryption. I'm going to look at what envelope encryption is in a little bit. Now, a quick comparison between cloud providers. Today, we have. I'm just comparing these three providers. Vault is not necessarily cloud provider, but of course, you can use it in conjunction with a lot of cloud services. So that's why I have put that in here. So in terms of key generation, AWS gives you both symmetric and asymmetric master keys. Azure gives you an asymmetric master key. Of course, Vault gives you both. Key length, in this case, AWS supports, by default, AWS gives you a AES-256 GCM, which is, GCM is authenticated encryption, which is currently considered the strongest mode of encryption when you're using any kind of symmetric encryption, right? It also gives you access to a lot of different RSA variants and ECDSA variants if you want to generate CMKs. And of course, you can log all of this in CloudTrail, in Azure Monitor, and in Vault, in the case of Vault, FileSocket or syslog. Now, all cloud providers and all of the encryption providers I'm talking about give you the ability to do something called envelope encryption. Now, envelope encryption is essentially where you are not, so every encryption starts with, or every cryptographic service starts with the concept of a CMK or a customer master key, right? Now, the customer master key is like the master key. You're obviously, that is the key that you don't want to be directly using for encrypting and decrypting data. Yes, you can use that. It's not a problem, but it especially when you're dealing with a highly performant and highly scalable system, doing that leads to a lot more network latency. It leads to a lot of delays in terms of performance. So what you ideally want to do is generate a intermediate key or a secondary key or a set of keys from that customer master key, which is called a data key. So in this case, we have two versions of that data key. We have a plain text data key that is used to encrypt any data, and the same plain text data key is decrypting that data. So the actual data key can be stored along with your database or some other location where you can access it quickly. And you need to decrypt that data key first with your CMK and then encrypt or decrypt any data that you want to use. You have to just store the encrypted copy of that data key in your database, right? So that's something that you do. So an envelope encryption works across all of these providers. So Azure, Google, Vault, AWS, all of them give you the ability to do envelope encryption. I highly recommend envelope encryption simply because you make fewer network calls to be able to perform a simple data encryption decryption operation. And in the case of scenario, so let's say you have a very specific customer requirement where each customer needs to have their own encryption keys. Now, instead of using a CMK, which means that let's say that customer leaves, you might have to rekey or rotate the keys. But in the case of this, well, let's say that customer leaves, you can delete that customer's data key as well, along with all of the other customer records. So that's something that you can do with things like envelope encryption, right? So I'm just going to quickly do a demo of this, and we're going to see how this works. And just give me a sec while on the side, let me open up my console as well. So I've written a small, we've written a small Flask application to demonstrate this, just to give you an idea of how this works. Just give me 1 second. Yeah, this is our application. It's a, and I'm just going to reduce the size. So yeah, so what's happening here is that every time a user signs up for my service, I am generating an encryption key for that user, right? So every time, let me just get into that. Every time a user signs up for that particular service, I am generating a new key for that particular user in this method. And this key is generated from the Amazon KMS API. So what it does, it generates a data key for each user and stores the encrypted version of that data key in the database. So let me just quickly log into my console here and figure that stuff out. Give me a sec. I think we have 10 more minutes. I'm going to try and just get this done in the nick of time. Right. So this is, I'm just logging into the console so that I can also show you what's happening in the console. So every user who logs in, who signs up for my service, also gets a data key, right? And each user gets that particular data key to be able to handle their own. All of the users' data sets are now encrypted with that user's data key, which means that it's not directly encrypted with the master key, it's only encrypted with that user's data key. And the master key encrypts that data key. So essentially it's a key wrapping process. So the master key encrypts and decrypts the data key, which encrypts and decrypts the user data. So that's how it works, right? So so whenever user needs to create, the user's password is encrypted with the same kind of a data key. The user's credit card number is encrypted with the same data key. So let's actually look at this working. So, and in the other thing that we've also done in this application is that we've used so we use JWT in this application, and we've stored the password for generating the JWT as a parameter in the Amazon SSM. So in the sense that it's stored as a secure parameter. So every time you need to generate a JWT, it's going to pull out the secure parameter from SSM and decrypts that parameter since it's a secure parameter, and then gives you the value of that parameter. So that's what's happening. So we're using all three concepts. We're using the encryption, decryption aspect. We're also using the key value store for secrets management in this example, right? So I am going to, I've already set up my user account. So I'm going to log in as this particular user. Now, as soon as I log in, you will see that I'm getting a JWT return, right? So this JWT, remember, has been generated with the password that is in our parameter store in AWS. So I'm going to use this for every subsequent request that we're going to make. So I'm going to first log in. I'm going to create a credit card number, first of all, and then we are going to look at the data in our DynamoDB database. So I'm going to change this to credit card number, change the URL to create card, and I'm going to submit the token along with it. So let's call this CCN 411111111111. Okay. Authorization. So I'm using HTTP as instead of curl because just a little easier to work with than curl. Hopefully it should work. Oh, I think I submitted a wrong token. Yeah, so you see the new card was created. Now, if I go into my DynamoDB and let's look at what's happening in DynamoDB. So if I go into this, you will see that every user has some data sets associated with them. So I'm going to quickly look at envelope tables. Yeah, that's the one. So if you look at this, you will see that we've created a user called test@test.com. The user's password is encrypted. The user's credit card number is also encrypted. And it's encrypted with a key that is specific to the user, right? So each user has, like I said, their own key. We're using the envelope encryption system. So the key is for that specific user. So if I create another user, that user is also going to get their own key, right? So, and every data set for that particular user is going to be encrypted and decrypted with this key, which is encrypted and decrypted using a master key from Amazon KMS. So envelope encryption ensures that you can have these kind of fast lookups, especially when you're dealing with highly performance oriented applications or scalable applications. You can do envelope encryption. Now, envelope encryption is not only a cloud thing. You can use this on the cloud. You can use this with Vault. You can use this with most secrets management tools allow you to do that. So envelope encryption is pretty common today, and it's a very useful feature of actually doing encryption and decryption and key management on the cloud. So that's something that you can keep in mind. So in my application, just coming back to our application, it's a serverless function that we've deployed. Let me just close this. So we have also restricted all of the parameters. So in this case, we've said that only allow these actions on this particular key, only allow get parameter on this particular SSM parameter. So there's no real sprawl. So the idea here is that we are restricting the attack surface, right? So if an attacker even compromises this app and is able to, gain access to the environment variables and then pull out the access key and secret and then use that to access whatever this application can access from the secure token service, you will see that the attacker can only do what is in this part of this IAM definition and nothing more. That's the idea behind providing the right privileges to ensure that this key is this encryption system is not compromised, or not, at least beyond this, is not compromised. Right. So quickly coming back to our slide deck. So this we've already gone through. So just a few conclusions before we close. So today I would say that secrets and cryptography, especially with the cloud and with modern tools, is great. It's better than before. In fact, with stuff like Vault, you can have a nice hybrid where you can integrate Vault to your AWS KMS and back it by those keys, which is great. It's a much more solvable challenge today. So let's say 7-8 years ago versus now, you see that this is not only more solvable, it's also actually quite simple to use in most cases. And the good thing is all of these services, the crypto service, the secret service, they're always backed by strong algorithms. So you're not really rolling your own crypto, right? One of the biggest no-nos with cryptography is rolling your own crypto. And this is something you don't really need to worry about with these cloud providers because they give you a lot of strong crypto algorithms, and they're constantly improving and making their APIs quite consistent. Of course, there's still some ways to shoot yourself in the foot. You do have bad IAM. So let's say you do have bad IAM privileges or grants that are very, very open-ended, highly permissive grants. Or let's say you're using envelope encryption and using ECB or some other insecure mode of encryption to actually encrypt data. You can still do bad things, but the propensity and the ability to be able to do those stupid things is much lower with a lot of these encryption services and secrets management services that a lot of these cloud providers do today. So With that, I come to the end of my presentation. I still think I have 3 minutes on the clock. So that was, thank you very much. And I hope you appreciated it. I hope you liked it. Thank you.
Yeah, that was fantastic. I don't see any questions yet, but yeah, that was a really great overview of secrets management. I really appreciate it, especially that you covered the multi-cloud applications and Vault integration.
Thank you.
Yeah, if anyone has any questions, please say so now. All right, I guess we don't have any questions. Thank you very much.
Thanks so much. Thanks for having me, and really enjoyed presenting here. Thank you.
A real pleasure. Thank you again.
Can you hear me now? Excellent. Let me see. I see present now, your entire screen, a window, or a Chrome tab. I have two screens, so I'm not sure what your entire screen will do. Oh, there we go. I think it is my entire desktop. Is it, good? Perfect. I probably will minimize or, go to a demo, but it'll be on the same screen. Ready when you are.
All right, Michael's ready for us. And yeah, with no further ado, let's you have the floor.
Excellent. Thanks, Ian. So, hi everybody. I'm really happy to be presenting here at OWASP on a tool that we're calling OSS Gadget. My name is Mike Scavetta. I am a security person at Microsoft, and I do a couple different things. One of them is specifically, I think about open source security and how teams can leverage all the wonderful things about open source and avoid security challenges around that. That leads us to write security tools, do research. We do some things around security policy and engineering requirements. I've been involved with OWASP for many years, more so going back a ways, but in terms of the OWASP guide and secure coding practices and a little bit of static analysis. At Microsoft, my team has released a few open source projects. Attack Surface Analyzer and Application Inspector were the two big ones over the past year. We released DevSkim about a year and a half or so before that. And right now we have a new tool in sort of public preview called OSS Gadget. So the problem that we had and the reason that we uh, wrote this tool was because we do a lot of at scale analysis. So this is static analysis, looking for things like backdoors, obfuscated code, things like that. And what we found is, within each ecosystem, there's a different way of getting access to packages. And if you have every tool chain installed, it's relatively easy. It's npm install or pip or etc. But having each of those available in every environment that you want to do this analysis in isn't trivial. And there weren't a way that we could see that there were no existing tools that just said just grab me a package regardless of the ecosystem that it was a part of. So what we did was we built a tool that kind of abstracted all of that complexity. So if you're downloading something from PyPy or Composer or Hackage or CPAN or NuGet, it figures out how to get access to the bits, and then it does things with them. It's cross-platform using .NET Core, so it's Mac OS, Linux, and Windows. It's command line, but we do have it packaged as a NuGet library, so you can actually integrate it into other things. It's definitely preview. It definitely has bugs. We're definitely making breaking changes. It's not the kind of thing that you would want to integrate into anything production. It's not really a production tool, though, to begin with. So it's meant for analysts, really. It's not meant for developers to use instead of NPM or instead of pip or anything like that. So the nice thing is that we wrote integrations for this is about 12 here, different package management systems, including things more general like the Linux aptitude system, and so it makes it really easy to grab a list of projects and do something with do something against them, and being vague about what the something is, because it's not just downloading the packages. Right now we have 6 tools. 4 of them, are just the command line examples here. So it's as simple as OSS download, npm leftpad, or calculate the project health for Django, or detect cryptography in Cargo MD5. And these things here, the package, this is a format called package URL. It's it's pretty nice because it gives a common format without having to use like real URLs that can change over time. This one always means the leftpad project within npm. So we support all of these. We support a kind of going versionless. So npm leftpad means give me the latest version of leftpad. Django 1.2.1 means give me exactly that version. And then you can do Django @*, which means do something for every version you can find. So the 6 tools that we have are listed here: OSS characteristic, defog, detect cryptography, download, find source, and health. I'm going to talk about 4 of these. So the first one is OSS characteristic. This uses a different tool that we wrote called Application Inspector, which we released in January this year, to look for interesting things about a package, interesting characteristics, things like it uses cryptography, it connects to a database, it connects to Azure Blob Storage or AWS S3 or SendGrid. It interacts with the file system. It creates users. These are things that aren't necessarily bad in any way. So this really isn't a security tool. It's more of a introspection tool to say, to give an analyst a view of, generally speaking, what does a component or what does an application do? So we think this is interesting because there are certain characteristics which are more security relevant than others. So you can use this to support a security initiative, but by itself, Application Inspector is not, it doesn't pass judgment in any way. It's really just telling you what it sees. So we wrap Application Inspector as a library, and we provide the glue to have it understand individual packages like we had back here. Application Inspector itself has a nicer UI. So if you're interested in that kind of thing, I encourage you to check out the GitHub site and use the full-blown Application Inspector. The next one is OSS download, and this is really just locating the package, the actual package archive, downloading it, and then recursively extracting it. the recursively extracting it was actually kind of interesting because most package management systems use different archive formats, and having something that would just, no matter what it was pointed at, extracts it and keeps going until it's done was interesting. I'm planning to release this as a separate NuGet package because I think it's super useful, and I haven't found anything else that does it. But it itself, OSS download, just downloads an OSS package. Detect cryptography is a implementation of a search for crypto math. So not using cryptography. So if I'm just calculating the hash of a string, it shouldn't find that. But if you are implementing a hashing algorithm, it should find that. So some of this is because, as a previous speaker said, you don't want to be implementing your own cryptography, but people sometimes do, and it's important to catch that when they do. In the open source context, it's important that to know where the crypto implementations that we use are. So we look for magic strings, and that magic strings being the constants that are just fundamentally part of certain algorithms. But we also do things like look for density of binary operators. The line there, the hash bracket I, that code that looks like that usually belongs in cryptography and usually isn't in anything except cryptography. So we think that gives a pretty good signal on things that one should look at. We're looking to expand this. There were better ways of doing this as well. So we'll be iterating on this over time. Interesting thing here is we actually use DevSkim as a library to implement a lot of this stuff. So it was a good it's a good combination of other tools that we've written. It also does its best to peek into binaries. So if there is a .NET binary or PE or ELF or even WebAssembly, it will do its best to decompile it and then search over the results for that. So even if you have a shared library or a DLL or something, there's a good chance that this will identify crypto within that. OSS Health is our estimator for the health of an open source project. And basically what we look at is using GitHub's API. So we're assuming that the project is hosted on GitHub. We're looking at things like the number of commits and contributors, the issues, and whether they're plain issues or security issues, the project size, complexity, the number of pull requests that are open, and recent activity. And we're combining all of that into an algorithm which we think is pretty good, and coming out with a score. And the score isn't meant to be precise in terms of that a score of 31 is always better than a score of 28. It's meant to be more or less that if you scored 100 projects and then you sorted them by their overall health, you would, and you looked at them, you would probably agree that the ones at the top were healthier projects. So it's meant to be a rough swag at how likely a project will be maintained in the future. So OSS Gadget is a new tool. As I said, it's in public preview. I'm hoping to get it released as kind of a 1.0 within the next, let's say, 6 to 8 weeks, maybe a little bit before then. But for now, I would love to get feedback, open issues, contribute, tell me where it could be used. I can do a quick demo as well. So let me see if I can do that. The demo is probably not going to be very interesting because it's just command line stuff, but we'll do it anyway. So, to download a package from npm, it just placed it in that directory. And as you can see, if I go in there, it's extracted everything. That's great. We'll do. So this is a pure JavaScript implementation of MD5. So it did identify that correctly. The crypto detection code is in its nature a little bit inexact because certain algorithms use the same magic constants as other algorithms. So sometimes we just can't tell. Going to keep picking on left pad. So the health goes out, and it requires a GitHub API token that you would provide as an environment variable to do this work. And I'm going to give you one other one which I didn't talk about in the presentation, but this was OSS defog. Let me actually go back here for a sec. So the purpose of this one, OSS defog, is to look for obfuscated code. So as part of our backdoor research, what we found is that sometimes code is squirreled away in a base64 encoded string and referenced, and sometimes that gets by the author through a pull request or compromised credentials, or just people don't notice it. So we started looking for ways of detecting this, and the implementation is pretty simple. It looks for base64 or hex encoded strings. It attempts to unencode them, or decode them, and then re-encode them. And if they re-encode back to the same thing, then they were valid strings. Now, hex is harder to do that for because just about everything works. But base64, it actually we do actually get a good amount of signal from it. So as an example, which one was it? This is an NPM project called Restify, and there should be one result, which is, so this string here is in the source code, and if you base64 decode it, it's admin joy pass 123, which is super interesting. It turns out the whole section is actually commented out, and it's meant as an example, so it's not actually a problem, but in a different context, we have found base64 encoded secrets that should not be there. So we felt pretty good about that. And that is my demo. So if there are any questions, this was a short presentation, but I hope I've given you a quick feel for what the tool is. We're going to be continuing to add more features and more tools into the toolbox. The way I've kind of been describing it is it's kind of like sysinternals, where it's a collection of tools that all kind of solve similar problems. Things like normalizing metadata so that you can do a more apples to apples comparison between projects, between ecosystems, is probably something we're going to do soon. And we're looking to improve each of the individual tools, like locating source code or calculating health, or certainly cryptography, over the next few months. So happy to answer any questions.
Well, there were a couple mentions. Yeah, Mr. B Wednesday thought this talk was super awesome. He says they say that they are learning so much, and yeah, I guess that's the only talk comment besides Isaac Evans saying how the OSS gadget is related to Application Inspector. Do you have a comment on that?
Sure. So OSS Gadget just uses Application Inspector. Application Inspector itself is available as a command line tool as well as a NuGet library. OSS characteristic just wraps the uh, application inspector library, calls out to it to do its thing, and then processes the result. The only reason that it's a super thin wrapper, and the only reason we're doing it is because application inspector is meant to run on a directory, and all of OSS Gadget is kind of package based. So it will handle going out to a PyPy or NuGet or wherever to grab the bits, extract them, and then run App Inspector on them.
Cool. And Abhay also asks if you get results in JSON.
Oh, right now, no, but you will absolutely. I'm working on like the right way to convey the results because they are all different, and I don't want to just throw everything into a JSON. I want to have a standard format for it. So JSON will absolutely be coming. Yeah.
Awesome. Great. Does anyone else have any other questions? All right. Nothing in Slack, and everyone seems everyone's they're saying thanks. Yeah, great job, man. Thanks for sharing your work.
Thank you.
Great. All right, that concludes the programming we have here. And thanks for coming, everybody. I hope you enjoyed this. And if you have any feedback for me, throw it anywhere. I'm highly available. So, very good. Thanks again to our speakers, and I hope everyone had a great time. And we'll see you next time.